Good morning, everyone. I hope all of you are fit and fine, happy, healthy, and everything is perfectly well at your end. I would like you to observe these pics and come up with the phenomenon that is shown here. Guess, you guessed it right. It is the refraction of light that we are going to study today. So the pic here that I'm showing is of a glass prism, and to the left of the prism you can observe the white light, and to the right of the prism you can observe the 7 different colors. So when the white light scatters into 7 different colors in its original 7 different colors, this phenomenon is called the dispersion of light. So anything that disperses the light into its 7 colors is called a prism. A water droplet may act as a prism. A petrol or oil droplets may act as a prism, and a prism as such we have seen, crystals we have seen, diamond. So there are multiple examples where we can see the white light being scattered into its spectrum. The 7 colors are called the spectrum of the white light. So refraction is the phenomena of bending of light when it enters from one medium to another medium. In prism, the white light enters from the air to the glass and it is bended, as we can observe in the pic, and scattered into its different colors. We can observe red bends least and the violet color bends the most. From their wavelength study, we come to know that the wavelength of the red is longest and the wavelength of the violet color is the shortest among the waveguide or the spectrum of the white light. The angle A is called the angle of prism. The ray entering the prism is called the incident ray, and the ray that exits out of the prism is called the emergent ray. Here the complete electromagnetic spectrum is shown to you, where we can observe the wavelengths of the various rays: radio, microwave, infrared, and there is a range of visible light that we can observe. Let's now study some of the phenomena that we observe around due to the refraction of light or other playfulness of light. We have observed the rainbow. Very frequently we observe the rainbow after it rains, and the sun shines immediately after the rain or during the rain. The rainbow appears opposite to the sun, so its direction is always opposite to the sun. It is a natural spectrum that appears in the sky. It is caused by the dispersion of sunlight by tiny water droplets that are present in the atmosphere. So the water droplets act like small prisms. So when all these little prisms combine, we get to see the beautiful spectrum that is the rainbow. When the sunlight enters a water droplet, it gets refracted and dispersed, and then it gets reflected internally, and finally the refraction takes place again when it comes out of the raindrop. Next is the twinkling of stars. We all must have observed if at some places pollution-free beautiful sky and the silent twinkling of stars. So this phenomena occurs due to the actual position and the apparent position of the stars. The starlight on entering the atmosphere, Earth's atmosphere, undergoes refraction continuously before it reaches to us, our eyes. So since the refractive index of the Earth's atmosphere is gradually changing, the bending of light towards the normal and the apparent position of the star seems to be slightly higher than its actual position. So this frequent changing of the apparent position, feels like that the stars are twinkling. Another beautiful phenomenon that we have observed is the advanced sunrise and the delayed sunset. The sun is visible to us before the actual sunrise and after the actual sunset. So the density of the air near the surface of the earth is slightly higher. The rays of the sun coming through the space enter the top of the earth's atmosphere and travel from the rarer to the denser medium. So they bend slightly towards the normal in each refraction and appear to come from the apparent position of the sun. So the sun appears to rise a few minutes before the actual rise, and the same phenomena is applicable for the delayed sunset, as the sun continues to be seen a few minutes later after it has actually set. And what causes the blue color of the sky? When the light hits our atmosphere, it separates into all its colors. So the blue light gets scattered maximum, and this makes our sky appear blue, while rest of it reaches our eyes as white light. So as we can see in the picture, the blue light scatters most and the sky appears to be blue to us. Ever wondered why the sun appears reddish at sunrise and sunset? This happens because when the sun is about to set, or during the sunset and sunrise, the sun is near to the horizon and the sunlight have to travel larger distance in the atmosphere. As the path is longer, the total amount of scattered blue light is more and red is less. Thus, the red color reaches our eye and the sun appears to be red. So it actually travels a longer path as compared to the sunlight that has to travel little lesser path towards us. The path of the light when becomes visible when it passes through a collide due to its scattering. So when a light scatters its path through a collide, its path becomes visible. The phenomenon is called dindle effect. It is a beautiful effect, and